Kat, are you good to record? Okay, thumbs up. So everybody, welcome to another community meeting. There are people joining as we speak. So this meeting, the theme of the meeting is going to be about SDFormat. Edifice is going to be presenting about that. Be sure to add your names to the attendee list. The rough agenda is on the agenda document. Everybody should have the link. It's shared on the community post. So we're going to start with some announcements just before entering the month's focus. Then Adis is going to be doing a nice presentation about SDFormat. And then after that, it's open agenda. We seeded it with some projects that we saw on the internet using Ignition during the past month since the last meeting. But everybody here is welcome to bring up topics for us to talk about. So let's start with the announcements. Gazebo ROS2 control is out. Alex, do you want to talk a little bit about it?
Yep, so Gazebo ROS2 control is out. We have been working with the guys of the ROS control working group, and we have released Gazebo ROS2 control package in Foxy. So you can install it from with APT and so on. You need to include, I mean, it's not like a port from ROS1 to ROS2. They have different things because ROS2 control have been redesigned completely. So probably you need to add some things in the SDF to make it work. And you can also use this with MoveIt, which is also released on Foxy. So that's all. And if someone wants to try, there is a Docker container, and if you find some issues or you want to improve something, as always, very welcome to review your pull request.
Cool, thank you, Alex. So the next announcement is about the Edifice Release, which is the next Ignition release that's coming up 1 month from now, a little bit more than a month. There's a timeline there on the document. So we're going to be doing feature freeze on March 17th. So this means that no pull requests adding new features will be merged from that date. Only bug fixes can come in after that. We're doing code freeze on the 24th, which means we're not going to be accepting any pull requests, and the code's not going to be changing unless it's something very critical. And at the same time as code freeze, we are going to be having a tutorial party that everybody's welcome to join. This is just a week where we have a spreadsheet and people can review test tutorials with the pre-release of Ignition Edifice to make sure that everything works for different platforms, for different methods of installation and so on. So if nothing very critical shows up, we're going to be releasing Edifice on the 31st. And if you want to see what's going to be on Edifice, click on that link there on this document, and you're going to see the roadmap for the Edifice release. That's it for announcements. Unless anyone else wants to bring anything up that is announcement-y, we can go to the main presentation. Okay, Adisa, you're up.
Okay. Let's see if I can just click here. Can you guys see that? Okay. Oh. Sorry, I need to get my notes on the side. All right. So welcome everybody. This is a talk on improved nested models in SDFormat 1.8, or another name for it is composition. The outline is I will first talk a little bit about the SDFormat proposal and SDFormat website, the sort of procedure we went through to get the design and review of the proposals. And then I'll review the post frame semantics. This is, I had a talk 2 years ago and Ross gone about this, but be good to review, so I'll do that. And then I'll mention how SD4 or the composition worked in prior versions of SDFormat, and then we'll delve into the new stuff. And then at the end, I'll have some extra info that might be interesting to everybody, not necessarily related to composition. So I will hopefully, okay. So this is the SDFormat website. So for recently, we've been using this format of proposing changes to existing behavior, going through reviews, do a detailed design of what the changes are, and then get them implemented. And so I would invite everybody to check this out. If you have anything you want to get, add to SDFormat, this is the SDF tutorials GitHub page. That's where this lives. You can create pull requests, review pull requests. There are currently 2 pull requests in flight. One is a proposal for adding better pose. This is for adding things like being able to express angles in degrees and things like that. And then this is one where we're adding the ability to modify parameters inside nested models. So with that, I'll go back to this. Oops, sorry. Next. Okay, so just a little bit of notation here. We use this format x_MP, where x is the pose and m is the frame m down there in model, and p is this frame p, the pendulum. And when we say x_MP, we're saying the pose of this p frame relative to the m frame. And that's just useful in the next few slides. So in SDFormat 1.6 and prior, you had poses, and each of the poses had strict rules and predefined rules about what it's expressed relative to. So each link, for example, the pose is relative to the model. Each joint is relative to the child link, and then there are some exceptions. But in general, you didn't have much freedom as to saying what frame is used to express that. So that's just saying these are the notations for that. In SDFormat 1.7, we added the relative to attribute in poses. So now you could say, I want to express the pendulum link relative to the joint that it's attached to. And that is sometimes very useful because you don't have to do any math. This is usually just the length of the link that you want to put there. And so it avoids duplication of pose data and avoids having to do manual computations. And this is kind of like how URDF is defined. Each joint's pose relative to the parent frame, and the child link is relative to the joint that it's attached to, and so on. And then we also added the explicit frame, which is the frame tag, and that allows you to have arbitrary frames attached to links in your model, and then reference them anywhere you need them. As I said, there's more detail on the website and on the previous talk about this. So composition or nested models before SDFormat 1.8. Excuse me. This has been available since version 1.4, and I think even prior to that. And there are 2 versions of this. So one is where you include a nested model like so with an include tag. And the way it works is all the links and joints inside the nested model get moved out of that into the parent model. And then to avoid name collision, we prepend the name of the child model into each link and joint, and everything, basically, every reference, everything that's found in every name that's found in the child model. And so this is kind of, like I said, it's been around for a long time. It's a little bit error prone because it uses string search and replace. So if you have like plugins and just different things in the model, it just looks at, if there's a link named L1, it goes through it converts the XML into a string and looks for anything called L1 and prepends child model to it. And so it could be a little error prone. And then when it comes to the next kind of nesting, I'll show in a little bit, it's directly nested models. It causes some ambiguity as to what the double colon is doing. So here you'll see double colons in a name, and it's kind of trying to create a hierarchy, but the hierarchy is in the name. So trying to look for child model L double colon L1 in this model, you don't know if you're trying to look for a model here that's called child model and then go into that and look for L1, or are you looking for this link that's named with this exact string. And this is what directly nested models looks like. It's model inside model. So and before SDFormat 1.8, these two behave completely differently, because the other one lost that hierarchy by just moving all the links up into the parent model. This one keeps its hierarchy. Unfortunately, this wasn't supported in Ignition. It was supported in Gazebo Classic, but none of this was supported in Ignition Gazebo. And then starting from SDFormat 1.7, we added frame semantics, but we didn't add that to nested model, so you couldn't use nested references, or you couldn't have references that go across model boundaries. And then the other challenge with this previously was if you have nested links in a joint, so like if a joint references as its parent or child link, a nested link, SDFormat didn't really validate those. It was up to the downstream application to do that. And so these were some of the things we were aiming to address. So let's talk about 1.8. So the main, there are two main motivations for our work here. And I should say, I should have mentioned this before. This work was all supported by TRI manipulation, and just acknowledgement for them for doing that. I appreciate that. And so so they had challenges using the current forms of composition in their workflow, and so the motivation for that was to improve encapsulation and add more explicit semantics for assembly. And I'll talk a little bit more about those and then in examples. And then the other thing was to be able to include models defined in other formats like YAML or just your own custom format without having to convert all of those formats into SDFormat. So this is more useful for applications that use SDFormat without Gazebo.
Do you mind if I add an additional use case to the custom?
Yeah.
Yeah. So for us, the acute use case for other formats, or to be able to inject different model definitions, is that for ERDIF, we do our own custom parsing. And given that our custom tags, we haven't really spec'd out how ERDIF conversion is supposed to handle custom tags in the ERDIF, we decided it was simpler to handle our own ERDIF parsing. And so being able to coordinate SDFormat, to not parse the ERDIF and let us parse it, so that way we can appropriately capture it, for the time being. Maybe it's not a good long-term solution, but it's a good like intermediate. And then as a side effect, you can also support the other, like for us, we'd be able to support other formats. So, yeah.
Right. Yeah.
Great.
Thanks. Yeah, and feel free anybody else to interrupt anytime. So the concepts that we came up with is, these may not be necessarily new, but the idea of that a model forms a scope. So inside a model tag, you can reference other things inside that model. You can say the pose of this link relative to another link inside that model, but you can't reference anything outside of that model. And that keeps that model self-contained, and you can take it anywhere and use it. It won't break because some dependency didn't have quite the right name or reference working. And then the idea of having just this API of a model. You have your frames, links, and joints kind of form the API of your model. And then when you bring them in as a component to build an assembly, you can just say, you can use those links and frames and joints as your posturing functionality. And just the idea that frames should be the primary interface element. So we could create things like the mounting points that in each model you can have the frame called mounting point, and then any new component you bring in, if you know that already has that frame, you could just reference that frame. You don't have to worry about knowing the pose of, for example, if you have a gripper, you don't have to know how that gripper's pose is in relation to your arm or anything like that. You can just say, hey, take this gripper, take the mounting point and put it here. And I'll have examples for that later on. So once again, the model scope, just to go into a little bit detail about this double colon syntax. So we're kind of formalizing what the double colon syntax does. You can reference things in the current scope. So right here, you have the relative to referencing mid-model, which is in the current scope of the model. And then inside that bottom model, which is this, and then inside that bottom, that's valid. Whereas here, the relative to is trying to reference top link, which does not exist in this model. I mean, there's a top link here, but that's not considered in the scope of this. So this is invalid. And that's what I mean by encapsulation. So I have examples. I wanted to, let's see, I might be able to run these. Okay, so can you guys see this? Is it? What's that, Luis?
We can see your tab.
Yeah, we can only see your browser.
Oh, really? Oh.
You're just sharing a window?
Okay, let me. How about that?
Yeah.
So all that time I was going through the SDFormat website, you guys didn't see that? Like I was scrolling through the website and clicking things?
We saw the website. We just
Okay. Okay.
Yeah.
Maybe you shared the window and not the screen. Okay. Cool. All right. So this is the just an example of using a nested reference. So you bring in a table, and name change the name to table one, and then I have a CoCan model, and I could say put that Coke on the top surface of table, and I've defined this frame inside table, and yeah. So and you can just say frame name top surface and give it and the pose relative to I guess in this case would be the canonical link, which is this guy. And so usually if you just, if I just took the, if I just took this without this information and put the Coke can there, I have to know what the height of the table is, and then I have to know the thickness of the tabletop and things like that. All that information is contained in that table model, and I don't need to know that outside of it. So Gazebo example 1, and that works. It's perfectly placed exactly where you want it. So then example 2, oh, and then I'm getting these back traces. I think we're in bleeding edge development, so never mind that. So for the next example, I have the table, but I also have it inclined a little bit, and that makes it even more useful to have this, because now if you wanted to put the Coke exactly at the top surface, you'd have to, do rotation matrix, multiply by, it's just, it's just annoying, and you have to do all of that manually. So I have all of these. And then the other thing I want to show is something we added called placement frames. And the placement frame is when I include a model like this and set the pose, it's like moving the pose of the model, but what is that frame exactly in the model, right? It's, in general, in the past, it's been what we call the canonical frame, which is the canonical link, which is the first link in the model. And if you have a sphere, for example, the center of that sphere might be the canonical link. But I want to say, move the bottom of that sphere to the top surface of the table. And that's what, so sphere, if I have base link, if I just define a sphere just like you would normally do it, this base link, the frame of this link will be in the center of the sphere. And it's now, you'd have to then, outside of the models, know what the radius of the sphere is and move it accordingly. But I can put that information here, create a frame called PL bottom, and put the radius of the sphere relative to the base link. And then here I could say the placement frame for this is the PL bottom frame, and then put that relative to the top surface. And then this is just moving it back. So let's see, so now you can see that it's inclined a little bit, but everything is, placed exactly where you want. And then, it works fine. Okay, so example 3 is kind of putting all of these things together in a more realistic, real-world example. I have the panda arm, which was recently contributed by Andre, I think is his name. I think he's here. But that model had the arm already attached, so I took that and made it into its own, or sorry, the hand was attached to the arm, so I made that into its own model. And so you can have, you would say, include the arm, include the hand, using the placement frame. Like I talked about, I created a frame called mount point inside that just points to the frame that is like where the connection is, the mating point between the gripper of the hand to the arm. And then this is another new thing we added in SDFormat 1.8. You can now have child and parents of joints be frames, not just links. So this is really useful. You could say the child so you can create a fixed joint between the arm and the hand by saying, here's the parent, it's the gripper mount inside the arm, which is a frame, and then child is actually this model. And it figures out what the link is by just resolving, each connection from starting from this gripper model to whatever, if there are other intermediate frames, it goes through that to find the link that it's connected to. And so that works pretty well. You could see that. But then if I comment this out, and the only difference between these two is that I have, I just changed this guy, right? I just said I'm going to use a new gripper, and just like that. I mean, it all just works because in both grippers I have the mount point defined, and then in the arm I have the gripper point mount defined. And as you can see, there are no numbers here because they're all defined inside the model, and it's just easy to create joins with them. Okay, so those are the examples I have. How are we doing on time? Okay. So the API for using all of this in the code. So usually you don't need this when you're using Gazebo, but if you're using SDFormat in your own application, non-related to Gazebo or whatever, this is the API you'd use to resolve poses. So the same scoping rules apply. You can only look down into a model. So here I'm getting the link of the link class, the link object of top link, and then calling semantic pose on that, and then I can resolve the pose of that top link relative to bottom link here. But I can't take I can't take, so if I wanted to do, if I take the bottom link and then try to resolve it to top link, I wouldn't be able to do that because that goes out of scope. And so we did that to kind of simplify parsing and just the code in general. It would have been nice to be able to reference to, at least in the API to reference anything, but for now you can only reference things down. Some of the internals, the way we are doing this in libSDFormat is it builds these two graphs, the pose relative to and the frame attached to graph. And as you can see here, this is what we use when you want to resolve poses. You can, if you want to resolve the F4 or M1 relative to F4, you can go down this path. And as it does that, it appends the name of the model. So F4 here is inside, well, I don't want to say something wrong, but I think if this is inside this model, it would end up being M1 : F4. But and then this is also used for validation. So if you have a frame, if your pose is relative to a frame, and then that frame is relative to the previous frame, so you have to sort of cycle, that's invalid. And so this is how we check that in this graph. If there's a cycle in this graph, that's an error. We also use another, so this is, I believe, the pose relative to graph, but there's also the frame attached to graph, which we use to resolve what link a frame is attached to and what link a joint is attached to. And earlier I said, a parent of a joint can be a model or a link or another joint even, or a frame. Well, the way that works is we can resolve what link it's connected to by going through this graph. And then the second, like in the motivation section I talked about, was to be able to parse custom files. And the way that works is we have this thing called the interface API. When libSDFormat sees a file that it doesn't know, it doesn't end with the SDF extension, it will call the custom parser registered in the application, and then that, does its parsing, populates its internal data structures, creates what we call the interface elements. These are like lightweight classes that only have frame information. They don't have like visuals and collisions and things like that, just frame information to go back to SDFormat. And the reason is, at this point, the custom parser has, that file can have visuals. It's just that the custom parser would have parsed those things and populated its own internal data structure. So it knows about the visuals. SDFormat doesn't need to know those because that application already has that information. So all SDFormat needs to know is the frames, joints, links, and nested models that are in that included file. So that gets sent back to SDFormat, and then SDFormat builds its frame graph. And then once all that is done, it calls the custom parser again with an object that helps it resolve poses so that you can reposture things. It's difficult for at this stage, at initial stage, to know what poses are relative to other poses until the frame graph has been built. So this is giving that information back to the downstream application. Okay, so that's how that works. It's not currently, it's still in a PR. I don't have examples, or I don't have a demo for that. But if anybody wants to look at that, I can go to the PR and show that. This is the, yeah.
We also have a PR against Drake, which is like the motivator on the QRI side for working towards this. So there's also still, I think you've polished it up, so now it's like, I think it's almost good to go. I've forgotten. Sorry. But we have
there are examples out there. Yeah, for sure. In the PR I've created, I created a file that you can define models and links in a TOML file, which is a file format, and then bring that in and read that into SDFormat. So there's an example for using that. Okay, so custom elements and attributes. This is something that we added actually in SDFormat 1.7, but I thought I should mention it. It's interesting, and it can be used in conjunction with composition. So when you want to use your own custom elements and attributes, SDFormat used to give warnings or errors, and now we recently in SDFormat 1.7 said if you define a schema like so, with the XML and S in the top level SDF tag, you can use your own types. You can use your own attributes and elements, and SDFormat will just happily ignore those. So you can define, vehicle here, and before it would have given you an error. Now, in order to avoid, a lot of verbosity, you can, if you have the element, the custom element defined here, the attributes don't also need to be foo.name and foo.type. Or foo::name and foo::type. You can just say name and type. Now, I say this, but I'll a note of warning here that this is all on the downstream application. It's up to the downstream applications to parse this correctly. This is just saying SDFormat won't give you an error. It will just happily take this and pass it on to you. And we use the SDF element pointer to retrieve custom elements. So you could say in this world element here, you could say get the string foo type, and you get that information. And let's see. So this URL here is just a string. It doesn't have to actually exist. It's just it's the standard way of defining schemas in XML, and you want the XML to be valid, and so this is how you do that. It's basically a convention. So TinyXML, the underlying XML library that we use, doesn't actually support namespaces. So this is really a convention for people to be able to use libSDFormat without and their own custom elements and attributes without getting errors. Some rules about how you can and can't use it. You can't use it to replace things. You can only use it to add new information. So if you have a cylinder and you want to say, oh, I want to use diameter instead of radius, you can't do that because the radius tag is required as part of the SDFormat spec. And if you just don't have that, it will give you an error. So you can only use it to add new information. You can also, you should also not break the hierarchy of XML elements. So a model and link. So a link should always be a child of model. Here I have a custom element that breaks the hierarchy, and that will not be acceptable. That will give you an error. Okay, and then the last thing I want to mention. Somebody unmute. Okay.
Yeah, sorry.
Yeah.
I think we're also currently discussing how to handle things like custom joints as well, just because that's an additional flavor of complexity.
Yes. So keep post. I think the latest on that is to say joint type equals custom, and then have your own joint definition inside that. But that's kind of still up in the air. We might have a new proposal for that. Okay. So the last thing I want to mention is the Shane Loretz from Open Robotics has worked on this extension of URDF parser to support usage of SDFormat or ROS2. Basically, it doesn't actually convert SDFormat XML to URDF XML. Instead, it's a plugin to the parser where it reads an SDFormat XML and converts it and populates the URDF C++ data structures. So you can use things like RViz with this. RViz can now read robot description parameter that's set in SDFormat instead of just URDF. So I don't have a demo for that, but I will link in the GitHub page for that. And just a warning that it's new project, and there are some limitations, but Shane's done a pretty good job of documenting what all those limitations are. So just feel free to look at that. And that's all I had, actually. So I'm open for any questions. Steve?
I had a comment. I was just trying to start using a custom element. I was going to add it to Gazebo. And I ran into a problem with Gazebo ROS when it was parsing that XML namespace for the spawn entity script. It's a Python script. I put a link to that pull request in there. So just an FYI, anyone who tries to use that and then parse those files in Python, beware.
Any other questions?
Cool. Thank you, Edisu. Maybe we can move on to the agenda. that was very cool. So let's see. I'm just gonna go over very quickly these things here. Like Kat found most of them on the internet. People sharing their projects online and some other things like this. So the first one is about the Mars Rover. So in case people were not following the news, like there was a rover from NASA that landed on Mars this week, and people are already simulating it on Gazebo Classic. There's already a model on ignition fuel. So there are a couple of links there in case people want to check it out. Like the model is on ignition fuel. It's in SDF. I think it uses SDF 1.7. I've seen some frames like relative to in there, so that's cool. And the other one is a video tutorial. It's pretty long and it's very detailed on how to simulate a Mars Rover on Gazebo Classic. So be sure to check those out. Yeah, like Adis is showing the sensor, the rover there. You can also like visualize it in 3D right there on your browser to check out the model itself. So it's pretty cool. Then next line is a post about migrating from Gazebo Classic to Ignition Gazebo. So we get a lot of questions from people about how to start the migration, how to, like, what versions to choose, if there are any guides. So this is kind of like one point for you to find a lot of links linking to resources to help you migrating Gazebo Classic to Ignition. We'd love to hear if anyone has like migrated a project or is not migrating a project for some reason. We would love to hear your experience migrating, or like why, you know, what's holding you back and what features you're missing, or you know what information you're missing, things like that. So be sure to check that out. Then the next one is the Move It support for Ignition. So we brought this up a couple of meetings ago, that Andre, who's here, is he still here? Opened this pull request for adding a joint trajectory controller to Ignition, and also made the integration with Move It 2. So all of those pull requests are merged now and they're released so people can start using them straight away. So it's very cool. So we wanted to highlight that, and the GIFs, of course, are super awesome. Then, and you know, tagging to that, just to let people know that World Move It Day is coming up in March. So it's a hackathon day where people can contribute to Move It. So you know, be sure to check that out if you want to contribute a little bit. Yeah, there are instructions there on how to sign up and everything like that. So the one below is ARIAC 2021. People who are not familiar with ARIAC, it's a competition on simulation using industrial robots. So the 2021 version of the competition is starting to be set up there on that repository. It's not ready yet, but you know, yeah, there's a nice screenshot there for people to check out the simulation. It's going to be using Gazebo and ROS. The next one, it's from our Singapore office. The Open Robotics Singapore team has been working on the robot middleware framework to get multiple robots synchronized, working in a hospital environment. They're simulating everything with Gazebo. They're using Gazebo Classic and migrating to Ignition Gazebo as well. So there is this nice blog post there on the Open Robotics blog detailing a lot of information about this. And there are some screenshots there of the simulation on Gazebo as well for people to check it out. And finally, a couple of nice tweets that Kat pulled up for us. This one is like the first robotics competition, which is a competition that happens here in the US for high schoolers. So it happens every year, and they are starting to simulate the competition. I think it's the 2021 competition. It wasn't clear there from the tweet, but it's very cool to see the competition moving to simulation and teams making use of simulation to train their robots and stuff. And the last one is this huge warehouse simulation inside Gazebo Classic with humans walking around. So very cool, a lot of clutter around that warehouse. So that's also some cool project. That's all we found. Anything else that people want to highlight, talk about, ask? We have about 13 minutes left if we want to fill them. People don't have anything? We can finish the meeting here. I just wanted to remind everybody of the Edifice timeline, and also to join the tutorial party to help us review tutorials in the end of March. And there will be also a t-shirt campaign coming up soon for you to get your Edifice t-shirts and all of that. Any final thoughts before we close? Thank you again, Adisu. That was a very good presentation. And thank you everyone who joined. See you. Bye.
Thank you.
Thanks, everybody.
Goodbye.
Thank you.